Okay, let's solve this problem. The question is, determine the force in member GE and GC and BC. Okay, so we have to use the method of sections in this case. So here, kindly, the textbook show us the cross-sectional plane, which is called by AA. If you look at this truss, there is a pin joint here. So pin joint has two support reactions, and this support reaction is just a one support reaction. It's a roller or rocker. So only there is only vertical restrictions. So which is dy. This ax. Oh no, never mind. This is ay. This one should be ax. Because we have 400 external forces here, we know that the ax should be directing left-hand direction. This is equal to 400 Newton. And if you calculate the moment at point A, then this 400 Newton and this 1200 Newton create a clockwise rotation, which is a minus sign. So this dy should be create a counterclockwise rotation. So that's why it can be cancelled out. So let's calculate the dy here. This 400 Newton create a counterclockwise rotation. Oh no, clockwise rotation. The vertical direction distance is 3 meters, and this 1200 is also create clockwise rotation. The vertical distance to the point A is 8 meters, and this dy, we don't know dy, but we know the distances, which is 12 meters. So this one should be, sorry guys, what is this one? So this one should be equal to 0. So when you solve this problem, this is the sigma moment A, then dy is equal, yes, this is 900 Newton, which is a positive upward direction. This one ay, we can automatically decide this one is 300 Newton upward distance, because this 300 Newton, we have a 900 Newton here, and we have a negative 1200 Newton. So that's why we can decide these unknown forces directly. But the question is, what is the forces in three members, GE, GC, BC. So let's draw the free body diagram. Let's design the orientation. Right hand direction is positive x, upper direction is positive y. You can choose this side or this side, it's really up to you, but I'm going to choose this side, the left hand side. Okay, so let me draw the free body diagram. And we found that there is 300 Newton upward. On the left hand side there are 400 newtons. We already found these values in the previous page. This is G, this cross-sectional plane, and we don't know these forces. C. Okay, so if you see that we don't know these three forces, let's assume these three unknown forces are in tension. Okay, so it's in tension, which means which is pulling forces from point B. This is pulling from point B. This one is also pulling from point G. This one is pulling from point G. So we have three pulling forces. Obviously, they may not are all in tensions. One of them could be the compressions, but we will figure it out later. So this one is BC. This one is GC. This one is GE. So three unknown forces. Okay. So directing right-hand directions, they are all in tension. That's our assumptions. The question is, which point we should choose to find one unknown forces directly? For example, if I choose point E, let's calculate the sigma moment point E should be equal to 0. Then you can see that this one creates the clockwise rotation. This one also creates the clockwise rotation. This one creates counterclockwise rotation. Okay. Oh, wait a minute. Not E, I think. We should choose C, I think. Sorry. Because this one creates another clockwise rotations, so it's gonna be difficult. Not choose E. Let's choose point C. Okay. Let's choose point C. Then this one, 300 Newton, create a clockwise rotation. And this 400 Newton does not create clockwise rotation because they are collinear. And this GE create, okay, I think this one should be counterclockwise rotation. Because this one already create the clockwise rotation about point C. So this one should be negative side. Okay, let's figure it out. Sigma moment at point C should be equal to 0. That means we have two forces are associating at the point C. That is 300 Newton create the clockwise rotation. So that is minus 300 Newton times the distance is 8 meter. So this is 4 meter, this is 4 meter, and the vertical distance is 3 meter. Remember, we can find that this is 4, 3. The diagonal direction should be 5. So 300 times 8. And we don't know, but we assumed that the direction is positive, right-hand directions. Let's keep the direction that is create a clockwise rotation. Minus GE times 3 is equal to 0. So GE, we can find GE directly from this one equation. So GE is minus 800 Newton. Like I said before, we got a negative sign here. So that means our direction, while our assumption was wrong, this GE not in a tension, this one is in compression. So left-hand directions. Okay, so this GE is 800 Newton, this is the magnitude, and this one you can see the direction of the GE. This force is pushing toward G. Okay, this is pushing. So this is 800 Newton compressions. GE is compression. Alright. Then let's look at the another moment. See. Aha. Okay. How about the point G? If we calculate the moment at point G, then we can find another unknown forces directly. That is BC. Okay. So let's look at the moment at point G. This 400 Newton. Sorry, guys. Okay. This 400 Newton create clockwise rotation. 300 Newton create clockwise rotation. And this BC should create counterclockwise rotation. So I think the direction is right. So 400 Newton times the vertical distance is 3 meters, and this one is clockwise rotation, so it's minus. Another one is 300 Newton times the vertical distance, perpendicular distance is 4 meters. And we don't know the magnitude of the BC. Vertical distance, perpendicular distance is 3 meters. This one should be equal to 0. So from this equation, we can directly find the BC is 800 Newton. 800 Newton, and this one is positive sign. So that means this one, we assume that member BC in tension, so this one is in tension. Okay, we already find two unknown forces. The last one is GC. Okay, last one is GC. How can you find the GC? There are many ways, but I'm going to choose the entire this truss is in equilibrium. That means the sigma fx should be equal to 0. Sigma fy should be equal to 0. Sigma any point moment should be equal to 0. So let's choose x-axis force. Sigma fx should be equal to 0. So let's list up all the forces that is associated the horizontal directions. So that is, first one is minus 400 Newton, this one, okay. And the next one is we know the GE, right? GE is left-hand direction, so this is 800 Newton. Another one, we know the BC. BC is right-hand direction, 800 Newton. The last one is GC. We assume that GC is directing right-hand directions. For the x-axis, we don't know, but GC, we know that the angle, which is 4/5. Here we have a direction information. So this one should be equal to 0. Now I can see that GC should be 500 Newton, and this is a positive sign, so based on our assumption, this one is still in tension. So you can check the solutions in the next slide. So you can check the solution. Please review this solution carefully because I'm thinking that this question will be appeared in the midterm exam too. Okay, so please review this problem carefully. Obviously, I will change some numbers here and here. Okay, here and here. You have to know how to apply the method of sections to figure out the magnitude of force as well as whether this member is in tension or compression. Okay, this is a kind of summary quiz. The first question is that in the method of sections, generally a cut passes through no more than blank members in which the forces are unknown. So we have three equations. So basically you have to cut the line should pass through the that has at the most 3 members. Okay, because we have 3 equations, more than 3 it's really hard to solve the problem. Okay, so choose the cutting line carefully. Question number 2, if a simple truss member carries tensile force, which is tension, along its length, then the internal forces in the member is, okay, A, tensile with a magnitude of T over 2, it's a half. Then compressive with the magnitude then compressive with magnitude of T, then tensile with the magnitude T. Yes, this is correct because the internal force, like I explained, it should be the same. It should be the same magnitude, and also the internal force is in tension. So the answer is D. We learned method of section today. Thanks for watching this short video. Have a great day.